Hello, today we are going to be proving the Pythagorean theorem. Now, what is the Pythagorean theorem? Well, it involves a triangle, a right triangle. And what is the Pythagorean theorem? You've probably heard it before. It's a squared plus b squared equals c squared. That's right. I'm going to put it right there so you remember. Now, you've probably seen this formula before and you've done it time and time again. But you probably, how does that happen? So obviously we start with a right triangle. They're very common today, and so this would be A, and this would be B, and this would be C. The hypotenuse is always the longest side. Now, the theory states that if we were to square this and square this, add them together, and then it would create the square of this, as seen here. Now, let's look at this. In a right triangle, there's always 90 degrees. It's always 90 degrees, otherwise it won't be a right triangle. And then there's these other two angles right here, these small angles. Now, let me just make this a square so it's clear that's a right angle. Anyways, so these two, let's call them angle heart, that's a heart, and angle star. Now, angle heart and angle star and right angle. Now, what is the rule with all angles in a triangle? They all equal 180 degrees. All right, so that would mean angle heart plus angle star plus 90 degrees equals 180 degrees. Now, we all know it's always going to be a 90 degrees because it's a right angle, so we can remove the 90 degrees, okay? And then that would mean angle heart plus angle star equals 90 degrees. Yeah, simple as that. That would mean these two angles are all complementary. I'm gonna write it down. Complementary. You get it. Okay, so that would mean I have some copies of the same triangle right here, as you can see right there. So if we put them out, if we have 4 copies of them, this is 90 degrees, and this is 1 degree. Whoops. And then we take this one up like that. Both of these would equal 90 degrees, and then that means this degree right here would be also 90 degrees. So if we if we put it up here, 90 degrees. And what do 490 degrees create? Sorry, I'm just gonna move this out of the way. Move all of this. What would 490 degrees create? It creates a square, which is kind of satisfying to see because it all comes together to be a big square. Now this is a big shape. What is this? This is essentially, how do I get the area of this? I would write it down here. This is essentially A plus B squared, since this is side B and side A, and then square it to create this big square. That is the area of this big square, including the space in the middle. So if we spread it out, A plus B times A plus B, which is A plus B squared, we just and then that would create A times A is A squared plus A times B is AB, A plus AB again, plus B squared, which, if you add it together, is A squared plus 2AB plus B squared. Now, you see that? That is the area. Another way of seeing this area is, of course, there's 4 triangles and 1 big square in the middle. So what is the area of a right triangle? It's right here. It's 1/2 times AB. Now, how many triangles are there? 1, 2, 3, 4. Now, if we take 4 times 1/2, that's AB, of course, and plus C squared, because this is side C, and it creates a C squared right here. So that, that would equal to 4 times 1/2 is 2AB plus C squared, of course. Now, these two, since they're all the same shape, they would equal to the same amount. Now let's factor these. Let's take 2ab plus c squared, 2ab plus c squared, and a squared plus 2ab plus b squared, a squared plus 2ab plus c squared. Now, what do they both have in common? Of course, you have to get rid of the common factor. It's 2ab. Take rid of that, they equal to each other. And then, of course, you have c squared equals a squared plus c squared. What the heck? B squared, sorry. And then b squared, and that would mean a squared plus b squared equals c squared. Which, does that look familiar at all? Of course it does. It's the Pythagorean theorem. I just proved the Pythagorean theorem. Another way of proving it, of course, if we go back to just a single shape, I have created some squares here. So this is a squared, which is, it creates that squared. It's equal to that. B squared right here is equal to this side. See, it's a big square. And of course, c squared right here. Let's label them real quick. A squared, b squared, and c squared. Now the idea is if you add these two squares together, it creates this square. Now, let's go back to our original big shape. Of course, if you take 4 of these, it creates this big square, which is c squared, which, as I said, this fits very smoothly and snugly right in between. And that would mean all 4 of these will equal to these two. It's equal to that. So, but that's not it. If we take out and then we move this, I don't know, right here, this right here, it would still equal the same shape. Or we could add a square right over here and b square right over here, which is essentially the same size shape, except you could fit in these two instead of this one. And of course, you can't lose space or gain space out of nowhere. It would equal the same thing.